answer. Number one, is inertia a force? No. This is a really easy one to get confused on. In fact, I don't know that I've ever had anyone get it right the first time, which is just explains how tricky this is. Here's why it's not a force. It is not a force because the definition of force that we had, any object that can cause a change in motion. Inertia cannot cause you to change your motion. Inertia cannot make you change your motion. Therefore, it is not a force. So inertia is a force is false. That one is not true. B, inertia which keeps it's inertia which keeps stationary objects at rest and moving objects in motion at a constant velocity. So I am being super, super anal on the semantics on this question. The key word there is keeps. Is inertia why those objects do that? It's kind of in how you phrase it. Keeping means actively doing something. Inertia cannot do anything. Inertia is the property of why this happens. It's kind of like, is color why? So why is something blue? It's not blue because it's blue. It's blue because you see blue. Does that mean the object itself is blue? It's kind of confusing. The answer for this one, though, is false. Inertia doesn't keep objects stationary. Inertia is why. It's the explanation. So it's inertia which explains stationary objects are at rest and moving objects in motion at a constant velocity. So it doesn't keep them, it explains it. So that one is true. Or sorry, that one is false. The correct answer was false. Good. C, inertia brings all objects to rest. That is false. Inertia can't do anything. Inertia is just the explanation. So inertia does not bring objects to rest. All objects have inertia? Yes, because all objects have mass. Okay? A more massive object has more inertia than a less massive one. That is true. Objects that are heavier are going to have more inertia than objects that are lighter. F, fast-moving objects have more inertia than slow-moving objects. That is false. Motion has nothing to do with inertia, only mass. And I know you're saying to yourself, okay, Mr. B, if I get hit in the face with a baseball going 100 miles an hour and hit in the face with a baseball going 20 miles an hour, it's not going to be the same. You're right. That's called collisions. That's not what we're doing. We're not doing collisions in this unit. We're just doing what happens to an object. What you're thinking of is momentum, and momentum does depend on velocity, but inertia is not. So fast-moving objects have more inertia. That's false. They don't. An object would not have inertia in a gravity-free environment. That is false. Even if there's no gravity, objects have inertia. So guess what? If you are going to throw a bowling ball on the moon, it's still hard. It's still hard to throw a bowling ball on the moon because bowling balls are still heavy. Okay? If you can't throw the Titanic on Earth, you can't throw the Titanic on the moon. Okay? And even the moon has gravity. Okay, let's go in space. Can I throw the Titanic in space? No, I can't throw the Titanic in space. It's too big. It's also in the ocean, but besides that point. Okay? Yeah.
So gravity doesn't affect like mass or weight?
Correct. No, it affects weight, not mass. That's what we're going to talk about in a couple of classes. We're going to talk about what's the difference between weight and mass. So gravity affects weight. It does not affect mass. So mass is a property an object has. Weight is the force gravity pulls on it. Last one, inertia is the tendency to resist motion. No, it is the tendency to resist change in motion. That's actually really good. Usually classes don't get half of them. So I'm very impressed. Again, I'm super, super, super anal on the semantics on this question. So you have to be really careful on the wording. But I really want to make sure you understand what inertia is and how it works.